What is artificial intelligence? How do artificial intelligence, machine learning, and deep learning fit together? Artificial intelligence is what enables computers to perform tasks that require human intelligence, such as perceiving, synthesizing, and inferring information. Although artificial intelligence and machine learning are used interchangeably, subtle differences exist. Machine learning is a field within AI that enables computers to learn from data without explicit rule-based programming. Additionally, there is a concept called deep learning. Deep learning uses brain-like neural network algorithms to solve problems. Artificial intelligence is an overarching term that encompasses machine learning and deep learning. Today's cars are equipped with artificial intelligence to include self-driving and safety features. Object recognition in self-driving cars use computer vision algorithms to identify objects in their surroundings, such as other vehicles, pedestrians, traffic lights, and road signs. Machine learning models are trained on vast datasets of images and videos, enabling them to recognize and accurately classify different objects in real time. Self-driving cars are equipped with a range of sensors, including cameras, LiDAR, radar, and GPS, which gather different types of information about the environment. Machine learning algorithms are used to combine and process this data, allowing the car to create a comprehensive understanding of its surroundings. Self-driving cars use machine learning to make decisions about how to navigate their environment. They can learn from past experiences and adapt to changing conditions on the road, allowing them to make safe and efficient decisions in real time. Self-driving cars rely on high-definition maps and precise localization to navigate their environment. Machine learning algorithms can analyze sensor data to accurately localize the car in its surroundings and match it to a pre-existing map, enabling it to plan and execute a safe and efficient route. AI can be used to recognize objects and images or videos, allowing computers to see and understand the content of the visual data. This involves training algorithms to identify and classify specific objects, such as cars, buildings, or people. AI can be used to segment images into different regions based on their visual characteristics. This is useful for tasks such as identifying boundaries between objects or isolating specific features in an image. AI can be used to restore or enhance images that have been degraded or damaged, such as images with noise or blur. This involves training algorithms to recognize patterns and restore missing or corrupted information. AI can be used to generate new images that are similar to existing images or create entirely new images based on specific parameters. This involves training algorithms to learn patterns and generate new content based on those patterns. Machine learning has the potential to help in the early detection and diagnosis of disease. Medical imaging, such as X-rays, CT scans, and MRIs, can be analyzed using machine learning algorithms to detect patterns and anomalies. Machine learning models can be trained on large datasets of medical images to identify abnormalities and classify them for diseases accurately. Machine learning algorithms can be used to analyze data on biomarkers, such as genes, proteins, and metabolites that are associated with various diseases. This can help to identify potential biomarkers that may be used to detect diseases in their early stages. Machine learning algorithms can be used to analyze electronic health records, EHRs, to identify patients who may be at high risk of developing certain diseases. This can help to prioritize screening and diagnostic tests for these patients. Machine learning can assist in the analysis of pathology slides by detecting disease cells and predicting the prognosis of a patient. This can help pathologists to make more accurate diagnoses and provide better treatment options. In this example, facial recognition is being used to detect strokes. Machine learning can generate chat and code through techniques such as natural language processing, NLP, and deep learning. For chat generation, NLP models are trained on large datasets of human conversations to learn patterns and generate responses to new inputs. There are vast amounts of data that reside in Facebook and Twitter feeds alone. The model chat generation can range from rule-based systems that match input to predefined responses. An example is when you chat with an automated airline chatbot to change a reservation. There is only so much an airline chatbot can do before transferring you to a human agent. Advancements in this technology use more sophisticated machine learning models like neural networks that can generate more natural and human-like responses. Chatbots are a common example of machine learning. Generated chat used in customer service, online shopping, and information gathering applications. For code generation, deep learning models, such as generative adversarial networks and variational autoencoders, have been used to generate code snippets, debug code, or generate entire programs. These models are trained on large publicly available code datasets and can generate new code based on the patterns and structures they learn. Code generation models can automate repetitive tasks, optimize code, and even generate new creative solutions to problems. Code generation can fix bugs and create unit tests for the generated code. Machine learning algorithms can optimize the semiconductor manufacturing process, resulting in higher yields and faster production times. Machine learning models can identify patterns and predict outcomes by analyzing large volumes of data from sensors and other sources, allowing engineers to adjust manufacturing parameters for optimal performance. Machine learning can be used to detect defects in semiconductor chips during the manufacturing process. By analyzing images of the chips, machine learning algorithms can identify patterns that indicate the presence of defects, enabling engineers to identify and address quality issues quickly. Machine learning algorithms can optimize the layout of semiconductor chips, resulting in better performance and lower power consumption. By analyzing design parameters and performance data, machine learning models can identify optimal layout configurations for specific applications, reducing the time and cost of manual design processes. Machine learning algorithms can be used to predict the behavior of semiconductor chips under different operating conditions. By analyzing performance data from chips and simulating different scenarios, machine learning models can provide insights into how chips perform in real-world applications, enabling engineers to optimize designs for specific use cases. Machine learning can detect anomalies in the behavior of semiconductor chips during operation. By analyzing performance data in real time, machine learning algorithms can identify patterns that indicate potential issues or failures, enabling engineers to address problems before they become critical quickly.